Hello everyone. So today I'm just making this video to review some of what I believe are the basic concepts we should know from high school coming into university level chemistry. So most of these are pretty fundamental, so a lot of these will feel super basic to some of you because you've already seen them many times before. But I do still want to make this video because due to the pandemic, it's possible that your class may have been interrupted and you may have missed something. So these are just some topics that I believe are the most important. And so the first one is actually stoichiometry. And so this one's quite basic. I'm sure you've been doing it for a couple of years now. And so we won't be going through an example, but I just wanted to still mention it as this skill is fundamental and expected that you know. Uh, because when you come into university, we will be dealing with, like higher level questions. And the last thing you want to be doing is get stuck on converting something from like mass to, anything. And so make sure you have a firm understanding of how stoichiometry works, and hopefully you don't get stuck in the little steps. So let's move on to some other things. So another really important one, I believe, is basic IUPAC nomenclature. So when we do get into organic chemistry, we will cover the basics of IUPAC nomenclature. But if you have done a little bit in high school, this will feel really basic. But just some basic things you should be able to know is how to identify some functional groups. And the functional groups that we will be covering will be clearly shown in class, the ones that you will have to identify. And kind of a general, like, something that you should know if you're dealing with IUPAC is how to find the longest chain and being able to properly determine its name. So we have an example here. So if we look at this, we have one, two, three, four carbons. So we know it's going to be something to do with butane. And we notice that this alcohol group is on the end. And so this is quite a basic functional group. There will be others that you'll have to know. But we can figure out that the name of this molecule is butanol or 1-butanol. Doesn't matter too much. We aren't too picky about the naming, but as long as you get the basic idea, as long as we can understand what you've written, usually it's good enough. So the next thing I want to talk about is periodic trends. These are incredibly important, and these will be covered extensively once we have knowledge of other topics in chemistry, and they will be explained in what I believe is a much more like fundamental way. But you should still have a good understanding of how these trends are shown on the periodic table. So we have this periodic table here. It doesn't have any of the actual details, but it just has the trends. There's the source. And these are just some of the basic trends that you should know, and you should be able to identify what these terms mean, such as electronegativity and ionization energy. Those two, I would say, are some of the most important. And actually, I'd say all of these are quite important, but atomic radius. And so make sure you understand, not just like memorize, but also understand why it is like this. And so let's go through some examples and I'll kind of explain my reasoning. So which is more electronegative, chlorine or bromine? And so we could either use the trends here to figure out, okay, by the way, chlorine is about here and bromine is here, I believe. So you could use this to figure out that chlorine is more electronegative, or you can try to reason through it. And I will be leaving links in the description so that you can kind of look at these topics more extensively and kind of understand all the reasoning behind it. And the links that I'll be providing are straight from the textbook that we'll be using this year. So that should be a good resource. So we can figure out that our answer in this case is chlorine is more electronegative. And then which has a smaller atomic radius, oxygen or nitrogen? So nitrogen is right here, oxygen is right here. And so we could look at our chart here and figure out the smaller atomic radius would be oxygen. Another way to reason through it really quick would be that oxygen has more electrons in its valence shell. And so that valence shell is more attracted to the positive nucleus. Therefore, that shell is smaller, or like that group of electrons is more attracted. So like the entire volume that I guess that the oxygen atom takes up is smaller. So we can circle that here, oxygen. Perfect. Okay. And now the main topic that I want to spend some time on is equilibrium because I believe this is incredibly important, especially when we get into thermodynamics, thermochemistry, all that stuff. Like you should have a very good understanding of this topic from high school. Um, Again, we will cover it in class, but it doesn't hurt to know something coming in, right? So, what is dynamic equilibrium? So, our textbook defines dynamic equilibrium as when the reactants are converted to products and products are converted to reactants at an equal and constant rate. Now, this doesn't mean that the concentration of both sides is equal. And this doesn't mean that nothing is happening, right? So the key word here is dynamic. Something is still going on. And so we can look at this in an example here. This is actually for another example, but I'll kind of use this to point what I'm trying to say. So like we have A plus 2B on this side, we have C and D on this side. So dynamic equilibrium doesn't mean that like nothing is going on anymore. It may look like it, but A and B are still being converted to C and C and D are still being converted to A and B. It's just the rate at which both of these are occurring are equal, so we can't really like maybe visibly see a difference, right? Okay, and so you can't talk about equilibrium too much without getting into what causes equilibrium to shift, right? So that the main topic there is Le Chatelier's principle, and this is definitely something I would recommend reviewing. So we'll go through a question real quick here. So we have a couple questions here actually. We have what would an increase of the concentration of A do to this equilibrium? So if we increase the concentration of A, we will notice that the equilibrium shifts to the right because in Le Chatelier's principle, it is trying to oppose the change, right? And so what we'll notice is that there is a shift to the right. Okay? And then if we decrease the volume, so I'll actually give you guys a second to try to figure this one out. Okay, so if we decrease the volume of our system, we will actually be increasing the pressure within the system, right? And so if we increase the pressure to combat that increase in pressure, the system will actually shift to the right because we see that we have 2 moles of gas. Here, I'll use a different color just to really emphasize it. We have 1 and 2 moles of gas on the right, but we have 1, 2, 3 moles on the left. And so if we shift to the right, we will decrease our pressure. And so this is also a shift to the right. All right. And so I kind of explained my reasoning, but this should be very quick and intuitive. This will really help you out with questions. Okay. And finally, I just wanted to cover endothermic, exothermic reactions, and then we'll kind of come back to Le Chatelier's. So we want to be able to interpret these graphs. I didn't label the x-axis here, but this is something that will be covered in more detail in class. This is actually known as a reaction coordinate, but I would leave that to the profs to explain. And but we still want to be able to make sure we can interpret this. So here we basically have A and B going to AB plus C. I've also written it right here. So what we notice is that there is an increase in enthalpy, right? And so that means we're adding energy to the system. This right here is energy that we've added to the system. And when we do that, we go from A plus BC to AB plus C. So that means that this must be an endothermic reaction because we're adding energy to the system. Okay, and so this next question kind of builds off that. And so what happens when we increase temperature? So if this question confuses you, a good way to do it actually I find is when you write it out, when you write out the reaction, if you add a heat term like this, and then you think of it as you increase the heat, right? So when we looked up here, when we increase the the concentration, the reaction shifted to the right. In the same way, when you increase the heat, this reaction shifts to the right. And it's an endothermic reaction. That's why I knew to put this heat term on the left here. And so this is kind of like I guess a trick to do it, but you should also sort of have an intuitive understanding of why in an endothermic reaction, when you increase the heat, it makes sense that the reaction will proceed to the right in this case. So I hope that was helpful. These are just some really fundamental and what I believe things that you should know coming into university level chemistry. Um, if any of this confuses you, please check out the links in the description. They're straight from our textbook, so they should definitely be applicable to our class. There's also more examples on those pages. And if you have any questions, feel free to leave a comment or contact me, and I'll try my best to answer. Thanks for watching.